All right, let's go ahead and get started. As I said last week, we did quadratic transformations. We did, transformation shifting up, down, reflect it downward, reflect it left and right, all that good stuff. So this week, we're going to take that to a different level because I want you to realize that the same things that we learned last week with quadratics can apply to any function. We can do those same translations with the same type of rules on anyone. So let me put up our, these notes are in Google Classroom and there'll be completed notes in there as well. So after we get all this filled out, you'll have a copy of that as well in there. But I want you to look at this function we have right here. There's not an equation for that function, right? We get all kinds of stuff going on. 3 linear parts, and then we have this curved part that's a half a circle, basically. And we're calling this function h of x. This is h of x right here. And we're going to do transformations with this h of x. So, number one, if we take h of x and we put a negative out front, what is that going to do to our function? What does that do to a transformation to put a negative in front of the function? You can put that in the chat, or if you want to turn on the microphone and answer that, but I'll wait and see what you think if you're not sure. Does it reflect across the y, Brianna asked. That's a darn good guess. But it only reflects across the y if the negative is with the x. If we take out the x and put in a negative x, that will reflect everything, because if x equals 3, now it equals -3 when we put a negative for the x. So instead of on this side of the y, it would reflect to the other side of the y. So think about this. If we can replace h of x with y equals, so h of x equals something, whatever it equals. And now whatever it was, it's negative of that. So that's going to change what the y value equals. If the y value was 7, it would be now be a -7. So if we want to draw that, because that's the only thing we do, we don't have an equation. So what we would say is this would reflect down. That'll reflect it downward because putting a negative out front. So since this y is 1, if it's a negative now, it's -1. So it'll reflect down. So that point would move down here. These are already 0. So a negative will not affect them as far as where those values are, those points. This is a -3. It will move up to a +3. And then this one's at 0. But all of these points in between there, everything, all those little decimals, because 1 is as high as it goes. It goes up to the 1. Those are all now negative values. So this function is going to look like this. It's going to go down. It's going to go up to there. And it's going to go back down to there. So that is h of x with a negative in front of it. It reflects it downward. So there you go. Ryan says reflects across the x. In this case, yes, it does. It reflects downward. So all the positive y's become negative y's. Now here's what Brianna was talking about. If we put the negative with the x, it is going to reflect across the y-axis. I know last week we had an assignment, and it had some of that were reflected across the y-axis. And I don't think we went into that in enough detail because we had a lot of people struggle with that. But some people, we had some problems where it was first you would shift it to the right 3, right? Maybe that was the problem. You started out with x squared, and it told you to shift it to the left, and this shifted it to the left. And then it said reflected across the y-axis. And then so some people figured out, said, well, if I went this way, my parabola, instead of it being shifted left, right, over the x, that would move it over here. Well, it would shift it the other way, but that's not the same thing as reflecting. Because if reflecting over the y-axis, that means this point is going to move over and be this point over here. It's going to reflect to the other side. When you just shift it, this point moves to right here. That's not the same thing. If we shift this 3 points over, all of this is going to move this way. It's not going to reflect. So anything on one side moves to the other side and vice versa. So a reflection means this x, that's 3, becomes the x over here at -3. And the x's that's 1 moves over here. This is going to stay up there. This is going to move to the other side. That moves to the other side. So we see in a reflection, all those x values go there. That goes there and reflects back up. So this is the same function, but we substitute a negative x in it. The x in the function becomes a negative x. So on this one up here, to reflect it over the y, we should have done that. Just made the x a negative x. See, instead of doing this, if we want to reflect that, we just make the x a negative x. So this is that reflection. All right, so let's look up here. I got another copy of this right here, so we'll have the same function visible. So if we just take the original function, this original h of x, and we put a 3 on the end, plus 3, what is that going to do to our h of x? We're just taking the h of x and adding a 3 on the end of it. If we had the equation, we'd write the equation out, and we'd add a 3 to the end of it. Hey, Kinsey says shift it up 3. That's absolutely right. So let's see. I need to write this up here. Reflect over y. So this one over here, and you said shift up 3. Yeah, that plus 3 is just going to move us up 3. Every y value gets 3 added to it. So instead of, let's start with the one that's on the y-axis. Instead of being a 1, it's going to move up to 4 because we added 3 to it. These, instead of being at 0, they're going to move up to 3. See, that one's at x is 1. That one's there. That one moves up there. This one's at the -3. It's going to move up to the x-axis at 0. And it's going to move up 3 here. So when we draw this, there is the same function with a plus 3. But what happens if we take that 3 and we put it inside with the x? Now the plus 3 is inside. We've added it to the x. Because this, when we put it at the end of the function, that moved it up 3. That shifted up 3. But it's different if we put it inside with the x, inside the parentheses. I'm seeing people shifting left 3, shift to the left 3. Ah, fabulous. Left 3. So we take the original function and we just move it over 3. So this point becomes here and here, and that would go up to the 1 right there. I almost put it too high because this just goes up 1 right there. And this goes down to the -3. Back up there. So there it is. The same function just shifted over 3 units. All right. So let's look at page 2. We got more that we're doing here. I'll keep our function on top where we can see that. All right. So now we're taking the original h of x and we're putting a -2 on the end of it. Just putting a -2. What happens when we do that? Shifts down 2. All right, you guys are getting the hang of this. I think you're understanding translations here, transformations. So we translate that down 2. We shift it down 2. 1, 2. That moves down to there. That's down to there. That's at -1 instead of +1. That's down at -5 down here. 1, 2, 3, 4. Yep, -5. And then this is down to, should be right there. So curves up, goes there, down there. Now notice none of this is changing the size or the shape. It's all exactly the same size, same shape. These are what is called rigid transformations. Rigid transformations do not change the size or shape. Everything's rigid. It's locked. It's locked into that size. It's locked into that shape. And we're just moving it around or flipping it over, but it's staying the exact same size and shape. So, all right, now we're going to take that -2 and we're going to put it inside. This went down 2. So now we're going to move it inside. So just like on the other page, when we had the +3 inside with the X, it shifted it left 3 because it was a plus. This one is a minus. So that's going to shift right.
Hi, Alyssa. It's so nice to see you.
And 2, because that was the number there. So it's a -2. It's going to shift it right 2. So let's take all these points, move them over here, and that one goes up. This one's down here and right there. So now we draw our h of x. Our h of x has been shifted over to the right. All right, let's move it up. Look at the next one here. Now this is 2hx. So this is a multiple outside. 2hx. What is that going to do to our shape? What is that going to do to h of x? Gets a little trickier here. It gets bigger times 2. That's correct, Ryan, but does it get taller, wider, both? What is getting times 2? Making us think a little bit more about that. This is kind of a hint, since h of x is the same thing as y. H of x is the same thing as y. What's being multiplied by 2, the x or the y? Well, 2h of x is basically the same thing as 2y. Yeah, Brian. So it's getting twice as tall. It's not getting any wider, but that's like 2y. So this is a vertical stretch times 2. Well, it's hard to write legibly with a marker. Vertical stretch times 2. Because sometimes it's hard for me to write legibly anyway. So listen. All right. So anything that's at 0 is going to stay at 0 because 2 times 0 doesn't change anything for the y value. So those 3 points are going to be where they're at. This one was at 1. So now it's 1, 2 times 2. So now it's up here at 2. This one's at -3 times 2. It's going to be down at -6. And this point in the middle where the circle goes up, went up to 1. Now it's going to go up to 2 because those points all doubled in size. Every point between there is now twice as tall as it was before. It goes up, there, it goes up to there, it goes down to there, and then back up. So it just stretched it vertically, right? Up and down vertically. It's a vertical stretch times 2. Now we're going to take that 2, and instead of putting it in front, we're going to put it inside the parentheses. And it's going to be 2x, h of 2x. But you can figure that one out real easy. What's getting bigger, the x or the y? 2x is going to make the x bigger. Absolutely. Thank you. Good job, guys. So everything, the x is 0 for that point. The x is -1, so it's going to move over to -2. This is at -3. It's going to move to -6. That one's at 1, it moves over to 2. That one's at 3, it moves over to 6. So it's not any taller than the original. It's just horizontally stretched. Horizontal stretch times 2. So we just stretched that. We didn't make it any taller. Now we're going to talk about compression because now instead of a 2, we've got a half. So our number that we're using is less than 1. So now we're talking about compression. So what's being compressed, the x or the y? What are we multiplying by a half? The y. Oh, you guys are on it. All right, so the x doesn't change. There's an x, there's the x. Instead of at 1, this is going to be only at a half. Instead of it's being at -3, it's only going to be at -1.5. So now this is a smaller circle because it only goes up a half. It goes up there, it goes down there. So it's the same width as the original, but it's only half as tall. Vertical, this is the vertical compress. Times 1/2. Vertical compress times 1/2. And now we have the 1/2 with the X. So as I'm sure you've already guessed, that means the X's are going to be cut in half. Instead of this being out at 3, it's going to be at 1.5. Instead of that one being at 1, we're at a half. Instead of that being at 3, it's 1.5. This is at 0, so it's still going to be at 0. This is a -1, so it's going to be a -1/2. So this still goes up to 1. That goes up to 1. That goes down to -3 and back up to 0. But horizontally, compress by 1/2. Horizontally compressed by 1/2. We've just taken it and we have squeezed it inward. Same height, still just as tall as the original, but it is compressed on the width. All right, this is our last two we're going to do. And I will turn you loose to show you our lesson and we'll turn you loose. And we got a lot going on this. We have a negative out front. We have a -2 in the parentheses with the X. And we have a +3 stuck on the end of this. So who can tell me what those three things are doing to h of x? We got a negative out front of h of x. We've changed the x to x -2, and we've added 3. What is going on? I assume some of you guys are typing because I know you got this. If you don't know all of it, tell me a piece of it. If you're not sure about all of it, tell me what you know. We got 3 things happening, 3 transformations. We have a negative, we have a -2, and we have a +3. We can take it piece by piece. Oh, let's see. Reflect over the y, compress, and over to the right 3. Well, I think you got some of that mixed up, Ryan. Let's look at this. Brianna says reflect across the x, shift to the right 2, and go up 3. Kenzie says shift to the right 2, up 3, and reflect over the y. Not so sure. Oh, and Ryan's saying, nope, it's the x, not the y. Okay, so let's take it piece by piece. Let's start with the +3. +3 means it goes up 3. Right? Okay, we can do that, up 3. The -2 means it's going to go right 2. And the negative h is going to reflect down. Reflect down. Okay. So reflecting down, right 2, up 3. You guys were all over that. Now we have to draw that. Let's see. So we're going to take, first we know it goes downward. So whatever we do, we're going to have to draw it upside down. And we're going to take this right here. Let's start with the point right on the y-axis. This point right here. Okay. In fact, I'm going to start out in pencil because we're going to start out with that point. So it goes up 3. 1, 2, 3. It goes right 2. 1, 2. And then it reflects downward. So being a +5, it's going to be at -5. Reflect over the x-axis. Reflects downward. Now let's think about that. Let's think about that with the next point also. So if we go to this point here, Starts there, goes up 3, 1, 2, 3, goes over 2, 1, 2, and reflects downward. So does it move down here or does it just draw upside down? That's the question.
Both of these are correct.
Let's look at that real quick. If I close this and open up a Desmos. And we're just gonna make up an equation. Y equals x to the 5th. All right, so that's the original equation. And let's make it, no, let's leave it x to the 5th. And then we're going to take that equation and we're going to say we're going to put a negative out front. And we're going to make that x minus 2 to the 5th. And then we're going to add 3. Ah, see, that's what I thought. The negative out front just flips it upside down, but it doesn't reflect over the x-axis. And that's why I generally haven't used that language. I just say reflect down. Without the negative, it's still where it's at. That's still the middle of the graph. It's just reflected up. The points that go down will go up when we put a negative in front of it. Now, when we put it inside, it does reflect over the y-axis. See, that does jump on the other side of the y-axis. When we put a negative x instead of a positive x, that happens. So you put a negative out front, it just flips it downward, but not over the x-axis. So be careful about that. So it's pointing out the two options here. So we have two options. It's up here and it just draws upside down, or it reflects over the x-axis. It does not reflect over the x-axis. This just means it reflects downward. So don't want you to get confused on that. So this point is still right up here. This point is right here. Oh, wait, shouldn't be too away from it, should it? Oh, I started this one in the wrong place. That's what happened. This starts out at y equals 1. So it starts at y equals 1, goes up 3 and over 2. So this should be right here. These 2 points are still just a distance of 1 apart as far as the y value. So the one that starts over here at 1, 2, 3 goes up 3 and over 2. So when we start drawing that, this goes down. It still just goes down a 1 because we have not done anything to stretch it. Oh, wait a minute. Something's wrong with our drawing. It reflected down. This would end up down here when we turn it upside down, wouldn't it?
Off by a little bit.
Okay, so how does that work? Well, I think on this, we do have to reflect it down and then go up 3 and over 2. Reflect it down, go up 3 over 2. So that 1 there would move down to the negative 1 because the y changed from positive 1 to negative 1, and then went up 3 and over 2. This one is a y equals 0, so it goes up 3 and over 2. That still stays right there. And this point here is that y equals negative 3. So it would become a positive 3, which would put it where this point is, but then it goes up 3 and over 2. So it goes right there. So this is going to draw, here, I'll do it with the red pen so we can see it all. That's going to draw there. That's going to draw there.
Okay.
So there it is. There's our same shape. It is reflected downward, but the negatives would reflect the downward. And then it went right 2 and up 3. So turned it upside down, went right 2 and went up 3. All right, last one. We have a 2 in front of our function. 2, h of x plus 1. So now we've got a plus 1 in with the x, and a minus 2 on the end. So what are the pieces of this going to do? Well, we know the 2 out front. We know what that does, right? That's a vertical stretch. Vertical stretch. What's the plus 1 going to do? Inside with the x. We'll take it one piece at a time here. Left 1. You guys are in the shift left. Left 1. And finally, the minus 2.
But Leo
minus 2 on the end, down 2. Okay, so a vertical stretch. So it's going to be twice as tall as the original, but it's going to be moved left 1 and down 2. So this is going to take left 1, down 2, right there, and right there. That's those 2 points. It's going to be twice as tall, so it's going to come up to here. This point is going to be left 1 and down 2, but it's going to be twice as tall. So you go from up there, it goes all the way up to here first, and then moves left 1 and down 2. These were on 0, so they didn't stretch. This one is at -3, so times 2, it's at -6. It's going to be way down here, but it goes left 1 and down 2, so that puts it down here, actually, kind of off our graph. And then we've got, this is at 3 to start with, but the y is 0, so 2 times 0 still stays there, but we go left 1 and down 2, puts it over here. So there's our same graph, except for it has been stretched times 2, left 1, down 2. Oh yeah, here I'll put the times 2 on that vertical stretch, times 2, left 1, down 2. All right. Fear not, your assignment is not going to be messing with h of x here. We'll look at our assignment because it's a lot easier than h of x. Here's what your assignment is. The h of x that we looked at is just to show you that any function, the same rules apply for transformations, any functions. So if you have the graph of y equals x to the third right here, and you translate it up 2 units, what do you do to it? Does x to the third get a -2 in the end? Do you put a 2 in front of it, or do you add 2 to it? 3 choices, multiple choice, 3 choices. Or number 2, if you have the graph of the square root of x, doesn't matter what function it is, square root of x, like our h of x was a real funky looking function, and you want to move it right 5 units. How do you do that? Do you put a +5 in with the x? Do you put a -5 in with the x? Or do you add 5 to the end of the equation? You have the graph of y equals x squared, and you want to translate it left 4 units. Do you make it x plus 4 inside the parentheses? Do you make it x minus 4? Or do you put a -4 on the end? So you have 15 problems. It just gives you different functions to start with and wants to know which one of these would achieve like this vertically stretched by a factor of 2. Oh, I'll show you the last one because the last one's a little different. It's still multiple choice. Here's the last one. The graph of x to the third is reflected downward, translated left 5 and down 3. If the answer is this first one, then draw a hat on Mr. Brock. If the answer is the second one, then draw a mustache or beard. And if the answer is this last one, you draw horns on Mr. Brock. So I'll give you a little fun one to go on the last one there. It's still just multiple choice. Which one is it? Which one do you draw? But you have 15 questions. So that is it. That is taking what we learned last week where it was just applied to quadratics, and we're saying those same rules that we used in quadratics last week work for any functions. Any functions. So you have a variety of functions on your assignment to look at. Just remember the rules. You can go back. These completed notes are on Google Classroom. So I've got all this h of x stuff on Google Classroom that you can look at. And if you need to remember which way it went, we wrote next to it what it is. Oh, this is shift left 3. And so same rules work for here. That should help you get through the assignment. So, all right, guys, I will not be here Friday because that's the state bowling tournament. We did well at conference, so now we qualified for state. So I'll be out Friday. So anyone that has below a 70%, you've got some extra time to get your grade up because I won't be holding class on Friday this week. So, all right, you guys have a great week. I'll let you go.